Hey, Mr. Harridan here, and we are going to do the classification of matter. What is that? What is going on? Oh my goodness, it's a shark! It's coming to get me! Okay. Anyways, matter. It can be physically separated. There are two different types. There are mixtures, and there are pure substances. Okay. Mixtures have a varying composition. Mr. Harridan, come on. They can have different percentages of stuff. You can have a 5% salt and 95% water, for instance. Or you can have 10% water and 90% salt. Okay? They have varying compositions. Pure substances have a defined or definite's a better word, Mr. composition. They are 100% pure. Okay? So, for example, like the element hydrogen should be 100% pure. Okay? Unless there is like impurities in it. Okay? So, if you have pure substances, there are two different types. You have elements like lithium, helium, radon, okay, that can be found on the periodic table. They cannot be broken down into any simpler types of matter. And you have compounds, which are chemically bonded elements, like NaCl, Fe2O3, which is rust. And to go from elements to compounds or compounds to elements, you got to do a chemical change. You have to form bonds between the to make the compounds, or you have to break bonds from the compounds to go back to the elements. Okay. Now mixtures, there are two types of mixtures here. There are what we call homogeneous mixtures. These are the ones that look the same throughout. These have one phase most of the time. Okay. Example of that would be Kool-Aid, because Kool-Aid has that red dye, the sugar, and the water. So those are three different things in it. Okay. And you can vary your Kool-Aid. You can have Kool-Aid with more sugar or less sugar, right? Or more food dye or less food dye. But it still looks red throughout for Kool-Aid. Another example would be air. That would also be a homogeneous mixture. Make sure you know that this word solution, whenever you see this solution, homogeneous mixture. Just say solution, homogeneous mixture. Okay. Heterogeneous mixtures. These have two phases. Okay. Usually you can see the different parts. Okay, the first one I will discuss is the suspension. These separate upon gravity. You can actually see two different phases, like oil and vinegar salad dressing would be an example of that. Muddy water would be another example. And then there's always my favorite suspension, vomit, because you can see the chunks of whatever people eat in there. Just saying. Okay. Now, some heterogeneous mixtures really don't look like two phases, but they really are, and they're colloids. These have the smallest particles, these have medium-sized particles, and these have the biggest particles, so gravity affects these. Gravity works on these and eventually separates them after hours and hours and hours. Okay. An example would be blood, because there's platelets, white blood cells, almost said black blood cells, or blue blood cells, or green blood cells. There's red and white, isn't there? Yeah, red and white in there. Okay. Another one would be paint, for example, would be another colloid. Okay. So let's look at these definitions here. Okay. Has a uniform, unchanging composition. That would be a pure substance, meaning it has a definite composition, is 100% either compound or element. They have the same characteristics and properties and compositions. These can exist as either elements or compounds. Okay? Elements are found on the periodic table. We call it the periodic table of the elements for a reason. Just saying. Okay? Okay. Takes a nuclear reaction to break elements apart. Okay? Because elements can be broken into subatomic particles, but they're not still elements anymore. Okay, then we have compounds. These are combinations of two or more elements that are chemically bonded. Okay, that's the key word here. They have to be bonded together to be a compound. Okay, to go from elements to compounds, or compounds to elements, you are going to do a chemical change. You're either going to form bonds to make compounds, or you're going to break bonds to make elements. Sometimes you do both, and sometimes you rearrange them. A bunch of other stuff that can happen there, according to Dalton. Okay. Then we have the next term here, which is a mixture. A mixture is a combination of two or more pure substances, each retaining its individual properties. Okay, so to go from pure substances to mixtures, or mixtures to pure substances, you have to do a physical change. You can take salt and water, which are both compounds, physically mix them together by making a solution, and you can make a mixture. Or you can physically separate them by like evaporating the water, for instance, and then you can have their salt back and your water vapor back. Okay, a physical change is required to separate mixtures back into pure substances. There are some methods for this here. Separating a solid from a liquid using filter paper, this is most popular for suspensions, would be filtration. Allowing the liquid to evaporate off and leaving the solid residue behind, that would be evaporation. That's most popular for solutions, which are also called homogeneous mixtures. And then to separate colloids, the most popular method is a centrifuge. This is used a lot in biology, especially in college, which I'll call it centrifugation. Okay. Basically, this is a big washing machine here, and it spins the samples around, and it separates them based off of their mass. Okay. On to page 3. Okay, so here we have a picture of an element, compound, and mixture. Okay, notice that there is only one type of atom in here in my element, and you notice that the hydrogens here are in pairs. This is actually a diatomic element. There are some elements that just bond to themselves. Hydrogen and oxygen are just two of the set. So, but this is an element because it has one type of atom. This is a compound here. Notice that this has chemical bonds between the atoms. Okay. These small ones are the hydrogen, this big one's an oxygen, this is actually water. This is hydrogen. Okay. And those are bonded together, and that will make water there. Okay. Here there is no chemical bonds between the hydrogens and the oxygens. So I've listed this as hydrogen and, notice I put the word and in there. Once I put that word and in there, that becomes a mixture. So this is hydrogen and oxygen that are not bonded together. Okay, Heterogeneous mixtures do not look the same throughout. These are the ones with multiple phases. Okay? They have pretty big particles and they separate upon filtration most of the time. Or you can just use gravity to sometimes do it too. Since these particles are bigger, these will scatter light. Okay, so this is what we call, the scattering of light is called the Tyndall Effect. Okay. So basically what happens when you shine light through the two type of heterogeneous mixtures, there are two types, there's colloids. Remember, these are the ones with the medium-sized particles. These will scatter light because the particles are medium-sized. Okay? And suspensions have the largest particles, which separate based off of gravity. These will also scatter light when it hits the particles. So both colloids and suspensions have the Tyndall effect. Okay? Remember, an example of a colloid here would be like blood, and the example of a suspension here would be vomit. Okay? Okay. Last one here. Homogeneous mixtures. Also known as solutions. Okay? Remember, homogeneous mixtures are the same thing as solutions. These are the ones that have one phase. Okay? They look the same throughout. Okay? Solutions don't scatter light. The particles are too small and they will not scatter light. Okay? Now, usually you think of solutions as solids and liquids, but there are other possibilities here. You can put gas into liquids here. That would be an example of soda. That would be CO2 in water. You can do gas and gas. That would be air. Air has nitrogen, oxygen, some water vapor in there, some carbon dioxide, and etc. Those are the main components of air. Liquid on liquid would be my example here. I like antifreeze, which is ethylene glycol in water. Okay. And solid here, there's a special term for this. This is called an alloy. Make sure you know this term. It's a solid mixture. Example of that would be brass, steel. These are metal mixtures. Okay. You guys are champions. The legend.